Thanks, everyone. I thought I would just talk openly and freely about what we do. I do two things that are very cool, and I'm very lucky to work with really amazing people, including Phil over there. The first thing is I created and I'm managing the data and analytics project at the Entertainment Technology Center at USC. And for those of you who are not familiar with ETC, it's the forum created by George Lucas in the early 90s. It's the forum where Hollywood talks about technology. And it's a really phenomenal space of dialogue and creativity because it's in sort of an academic setting, right? But it's very directly plugged into all of the 6 major Hollywood studios. Our board are the CTOs of all the studios, plus a bunch of really, really interesting tech companies like IBM and Verizon and stuff like that. And so those aren't just conversations. They're we try to build things most of the time. So, and the data and analytics project seeks to help the studios accelerate the deployment of data and analytics solutions, including advanced solutions like AI, in the entertainment industry. And I'm happy to report that, contrary to what's being said, the entertainment industry is moving extremely fast to implement a lot of the solutions that maybe other industries have implemented. And so there's going to be a lot of really, really exciting things coming in the next few years. And some of the stuff that we do there are sort of fairly cutting edge and new, and the amount of interest that we're getting from the studios really tells me that they're very, very, very serious about moving in that age of data and analytics. For example, what we're doing is one of the really exciting things we're doing there is we've successfully mapped very, very specific story and character mechanics to box office returns. So we're able to, the story is and I'll mention it a little bit later, but story is sort of the 900-pound gorilla in the room for box office predictive models. They're modeling a lot of things, except to me the most important thing, which is story. And there's never been a predictive model that's successfully modeled how types of stories and how they would generate, or types of characters and how it would generate more or less box office returns by genre. We've done this very successfully, and it's a very, very cool study that's gonna go out in a few weeks. We are doing a lot of other things, including researching a mathematical theory of what's interesting. It has to do with, so we're leveraging a lot of neuroscience concepts. It's the superposition of elements that are familiar to the human mind and elements that are new and innovative. So if you look at Pixar has this down to a T, even though that's not a science. We're making it a science. We're measuring it mathematically, and that's also a lot of interest. The second thing that I do, which is also very cool, is I'm extremely privileged to work with probably some of the best minds in the world tackling one of the greatest challenges in the world, which is artificial general intelligence. CEO of Novamente, working with people like Ben Goertzel, who's probably the best AI engineer in the world. Ben's written the mathematical blueprint for human-level intelligence, right? We talk about Elon Musk and OpenAI, and OpenAI doesn't have that, right? The only mathematical engineer blueprint towards human-level AI is Ben. And so we're doing a lot of cool things. We work with DARPA, IARPA, CDC, NIH. Our architectures are really about sort of symbolic reasoning, right? So we really, really create this very, very complex AR architecture that really, where agents sort of are able to reason in the face of a lot of uncertainty and ambiguity, with just the same way that the human mind is doing. And by the way, just a few definitions. It's a pet peeve of mine. So AI versus machine learning, right? I get asked that all the time. Machine learning, learning machines. Artificial intelligence, thinking machines, right? There's a huge difference between the two. Learning is a huge layer in AI, just like it's a huge layer in our own intelligence. But if you're doing, if you're running deep neural networks on image recognition, stuff like that, really complex, really hard, not AI, it's machine learning, right? And there's a lot of confusion around it because a lot of companies have you know, interested in sort of marketing their solutions as AI. A lot of it is not AI. We were just at CES, and it was a little bit frustrating for me to look at what everybody was calling AI, which is really not AI. And so, and as part of AI, so the difference between the two is fairly simple, right? And AI is a very specific domain. An agent has to have, so AI creates, seeks to build agents that have, that take action in the real world. That's also one of the big differences between machine learning and AI is an AI agent will take action in the world, will represent knowledge, will reason about data that is sparse and diverse, and take that data and represent the environment that the agent is in, represent itself, the environment, and its interest in that environment. So number one. Number two, it will learn, and it will take action. That action is really also separates machine learning from AI. A lot of machine learning systems or classifier systems, they don't take action in the real world. And number three, an AI architecture will have that recurrence of measuring performance from the action that was taken, and then layering that performance results into the models. So at Nova Material, we create real AI architectures. Our team is the team that created and is managing the OpenCog project. For those of you who are not familiar with the OpenCog project, it's just open source human level AI, open source AGI. So the difference between narrow AI and AGI, so narrow AI is an AI agent that will perform at human level or higher in a very, very narrow set of tasks. And you can't take that paradigm of that architecture and apply it to other tasks. So you can't take, a self-driving car, for example, is a good example of narrow AI, right? It's performing at human level or above, but you can't take that paradigm and apply it to trading stocks. AGI is an AI architecture that generalizes across domains. And generally, you look at how applicable an AI architecture or system is to a variety of domains. That'll give you an idea of how sophisticated it is. Right? If it's very narrow, the narrower your use case, the easier it is. It's still hard, but the easier it is. The broader the use case, the more symbolic reasoning has to happen, the harder it is. What I wanted to tell you today is, sort of look at how we are applying machine learning and AI to audience intelligence. If you look at demographic segmentation, it is less and less predictive of consumer behavior, especially in entertainment. The same demographic profiles will have a radically different profile of consumption of entertainment. So what we've decided to do is we've decided to segment people by the kind of stories that resonate with them positively or negatively. So as I mentioned, we took a database of 300 movies that were tagged to a system called Dramatica. And Dramatica is really, really interesting, and I really very highly recommend you go and check it out if you don't already know about it. Dramatica is a taxonomy of story forms, of structures of stories in film. It's extraordinarily complex. We've had to, and Marcello here did the analysis. It was very complex. It was 72 variables with some of them with levels, with dozens of levels. So it's a very highly dimensional space. But Dramatica is really interesting because it is complex enough to represent story in film and character in film in a very granular manner. But it's not an open system. It's still a closed system. So it's a very complex system, but still a closed system. which allows us to be both granular and systematic. Usually it's either or. You're either granular, but it's too complex to be systematic, or you're just too systematic and your analysis is a little bit biased. This was really cool because we had really extremely specific, down to the scene level, tags for 300 movies. And so what we did, we plugged in box office returns and we did an analysis and looked at, hey, what are the story and character mechanics at the scene level that make more or less money at the box office? And that's not AI. That's just very simple sort of data analysis. But it has an implication for AI, which I'll talk about in a minute. There's a lot of really, we learned a lot of really, really cool things. If you want to know more, I'm happy to talk about it in the Q&A. The bottom line is we have this sort of algorithmic now system of narrative that we're applying to marketing and advertising, right? Because the Dramatica narrative applies to everything. It literally, if you talk to the creators of Dramatica, it goes all the way back to E equals MC squared. I mean, it's scary how amazing it is. And it's extremely algorithmic, right? Because characters can have a specific set of motivations, but it's, it's a finite set of motivations. There are, it's a sort of a little bit like a Rubik's Cube. So it's a very, very complex system, but it's also finite. So what we did with that was we're taking this into marketing and advertising, and we're building a platform called Contender, which is a real AI platform. It's an autonomous content marketing agency, and what we do there is we mine social media for all the conversations, and we apply layers of intelligence on this conversation where people talk about Corona. What do they talk about? When people talk about Ford, what do they talk about? What's the story there? So, and we're really able to, and that's super interesting for brands because we have a completely programmatic way of analyzing brand equity, and we're also mapping that to their sales. So the whole holy grail of marketing of like, hey, this is the story you're putting out. These are the attributes of the story. This is how the story is received in your customer base, in your audience. And these are the attributes that are making you the most money, and these are the ones that are not making you a lot of money. And this is how the story is evolving, and this is how interesting it is. And this is your interestingness score, because we measure interestingness. We're able to tell brands that. It's something called Contender. You'll hear about it. It's coming out in beta form in a couple of weeks. Sorry, this was a little disjointed, but I'm happy to take your questions. Yep.
So on that theory, if you can programmatically determine what's interesting, then there'll be a race to kind of converge all brands to converge on the same types of stories.
No, because interestingness is dynamic. So let me unpack that a little bit. So it has to do with compression rates. And by the way, we didn't invent the theory. It's a guy named Jürgen Schmiedhuber invented it in Switzerland, AI researcher in Switzerland. We're the first ones to put it in production, though. Your brain processes data with compression, with various states of compression. If you're in a very, very familiar environment with a family member, or you're watching a movie you watched many times, or something is really, really familiar about this situation, your brain will not need as much data to represent that situation. So the compression rate is going to be really high, and that explains, why relationships fail and why things are boring and stuff like that. On the other hand, if you're in a very unfamiliar situation, your brain is going, if you're in a foreign country, if you're learning a foreign language, your brain is going to need as much data as possible to represent that new situation. Turns out there's a perfect point of superposition between enough elements of intimacy and enough elements of newness to make it really interesting. So Pixar has that. That's a whole sort of magic behind Pixar is they've figured it out. Right? Every Pixar movie has the same ratio of really profound, intimate themes that we are all very familiar with, but treated in an extremely innovative way. So if you look at Inside Out, for me, Inside Out is the ultimate perfect case of interestingness, right? It's about something that we can all relate to, that's extremely known and very, very intimate and very powerful, actually. But it's treated in the most interesting, in the most innovative way, right? That's the stuff I'm talking about. And so it's a dynamic thing, because things that are new become familiar, and so it's in the brain constantly is looking for ways to train itself on new data. If you see babies, they always look at strangers like very intensely. They're training on new data. That's what it is, right? So that's interestingness, yeah. Yep.
I'm curious when you talk about story and structure. If you go back to about 100 years ago, when we went to serialized stories through comic books and radio shows and things like that, where you had a story where you had the same characters coming back week after week, as opposed to living one story and then moving on.
Mm-hmm.
Do you see a similar change or anything different going on, both in what you're doing right now in terms of story and narrative, but also I'm thinking about the previous speaker who talked about us being infinite and longevity and some of the research into physical longevity that can happen. And if we don't have a sort of a 60 or 100-year lifetime that where our story ends, which could go on forever,
Mm-hmm.
do we think about ourselves in different ways?
Yeah. So I haven't done any work on serialized stuff, and that's kind of the next step, right? We're looking. We didn't do work on TV, for example. It's just film and marketing. Pardon me. But the beauty of that's why the Dramatica system is so elegant. It fits every single story. It's just applicable to anything, because it is really about. It reflects the cognitive structure of how our minds process reality. Because story really is an algorithm, right? It's a compression of an extremely complex environment to something that is a lot simpler and that we can learn from, and that is a vehicle for us to make decisions, because we can't make decisions if the environment's too complex. So our brain, again, has to compress that complexity into something that can lead to us making a decision in in the real world. Which, by the way, I have to wrap, but the point of story is that the connective tissue of all of this world of data that we live in, with all this feedback, et cetera, that really isn't really right now driving a lot of value for us. I mean, no, I don't think anybody's uses their fitness trackers past the 3 or 4 month mark, because it's just it just doesn't it's just too much time. Well, so AI is we need. I published something in ET-centric yesterday that's called the connective architecture. We need that connective architecture between all of these sensors, and that connective architecture is AI, because AI can process that data in very, very meaningful ways. But also story. And AI and story are very, very complementary. Artificial intelligence really can tell us the whens, the hows, the whats in a very sophisticated way, even the stuff that we don't already know about the universe. But it can't, this is very hard to tell us the whys. And the whys are stories. So that's why I'm interested in story and AI, is because AI needs story. AI needs Dramatica. AI needs that theory of story to understand, to create meaning. All right, that's it.